Good afternoon, everyone. Welcome to the continuation of the Developers Webinar Series. We're on part 3 right now. We have Chris McTaggart on the line today, who is our Radar Program Manager, and he's going to go into the quality assurance and quality control portion of the PHIUS certifications. We did record the first 2 parts, and they're available online. You will receive a follow-up email at the end, and we will link you over to those. This one's being recorded as well. We will distribute that link as soon as it becomes available. I think that's about it from my side, so let me introduce Chris McTaggart.
Thank you, Katrina. Hello, everyone. Good afternoon. Thank you for joining us for the 3rd installment of the PHIUS Developer Series. This presentation is going to be on the PHIUS Plus program quality assurance and quality control provisions that are built into the program. Before we get started here, I'd like to give a special thank you to the MacArthur Foundation. The MacArthur Foundation has provided sponsorship for this presentation that you all are seeing today, so thank you very much to the organization. My name is Chris McTaggart. I work as the Quality Assurance Manager and PHIUS Plus Radar Program Manager with PHIUS. In my role, I basically work in reviewing the submissions that come in from PHIUS Plus Radars on projects that are being wrapped up for certification. What I'm really involved in is really just reviewing those submissions to make sure that the PHIUS Plus Radar or on-site verifier gathered all the necessary documentation on projects to submit, so that we are ensuring that all projects meet the provisions of the certification program. In addition to that, I teach the PHIUS Plus Radar trainings and offer additional mentorship and support to PHIUS Plus Radars that's ongoing. So today's presentation, once again, is on the quality assurance, it says principles, that should say principles and processes for the PHIUS Plus certification program. So the principles and processes that we are going to focus on today are really how can you bake in from the very beginning, how can you really from the very start of a project, from its very inception, begin to think about quality assurance and quality control throughout the life cycle of your project. This shouldn't be something that you just think of as coming at the end when the Radar or PHIUS Plus verifier comes onto the project to do testing and verification work. You should think about it from the very beginning when you're creating your high performance design and creating a work scope in order to ensure that that design is properly executed on site. So in order to kind of give you some ideas on that, we are going to discuss what we think is a good design team checklist. So something for, you know, maybe it's the CPHC, maybe it's your GC firm, but whomever is really involved in really creating, you know, the design and building into that design methods to enable quality control throughout the process, because really the work of the on-site verification of the PHIUS Plus Radar or multifamily verifier, really the intention of their scope of work is to simply be a third-party impartial verification that all aspects of the program standard were executed on site. So ideally they show up and there's 0 problems whatsoever because you spent the time on the front end of the project to build into your processes a quality control program that ensured that you actually achieve the intended results from the implementation of your passive house project. However, that's not always how it goes. Sometimes there are not 100% adherence to what the original design or the plans or specifications or energy model said was supposed to occur on the project. That's why we have an on-site quality assurance program that is a third-party Radar or multifamily verifier verified process. So we're going to be going over what that process really looks like, and then also what the final step to certification is, which is the final certification review and quality assurance review of the work of the Radar. So in terms of integral planning for quality control, once again, this is sort of your team's attempt to build in quality processes from the very beginning of your project. So when you first decide that you want to achieve Passive House certification for your project, at that point, you really, it's one thing to start digging into energy models and creating designs that show very robust building assemblies and whatnot. However, that's just one component of how we arrive at a Passive House certified project. Really highly insulated building assemblies aren't going to do a lot if they are not planned to be thorough and continuous throughout the entire project. Also, our airtight layer is not going to be able to really perform at the robust and stringent requirements of the program standard if we don't plan for all the different transitions and phasing of construction and how different subcontractors are going to intercept with those applications. So really you need to start thinking about how you're going to execute on these details from the very beginning of the project. So really the goals here are that we're meeting a certified or certifiable project. That's the end goal of what we're attempting to do as a project team working within the Passive House standards. So really the reason why we're trying to do that is because if we meet the climate-specific space conditioning demand, that means we're going to arrive at a high degree of thermal comfort for occupants. We're going to have occupants that feel very comfortable in the built environment without the need of excessive space conditioning, really not only in terms of temperature, but then also in terms of, a consistent relative humidity throughout the course of living inside the building. We're also approaching Passive House performance goals in order to have meeting a stringent primary energy demand, and the reason why we're doing that is because we want to enable the occupants of the building to have a high quality of living with all of the modern amenities that we all come to expect in terms of living in buildings, but we want to deliver that as low of an environmental impact as possible. They're using as little energy as possible. So that's really our intent and what we're trying to execute on. And we want an airtight building assembly, not just because it helps us arrive at a low energy product, but more importantly is because it is a very durable and sanitary end product. If we don't have uncontrolled airflow moving throughout the building, then there's less of a chance that we may be moving moisture through building assemblies and potentially causing condensation or other types of long-term durability issues. So those are really kind of the three main principles of passive building. But in order to get there, we need to think about the other items that are going to intersect with those quality processes, such as what's the quality of our building envelope? How are we designing the building envelope to be continuous and thorough so that we don't miss any crucial details that could cause failures at some point in time? Most likely in most projects you're going to have some form of mechanical system. At the very least you're going to have a ventilation system, but more likely you're going to have heating and oftentimes cooling system as well. So how do you plan for that to really be as appropriately sized and designed to really keep people comfortable and happy living in their buildings? And then how do we execute on all the other associated details of really a high performance project? So these are the things you need to be thinking about from the very beginning. In terms of, Passive House, where we really probably should get started in our design, we should probably get started with the envelope itself. And the reason why I would get started with the envelope in terms of thinking about a quality Passive House design is that, really the quality and the detailing of the envelope is going to dictate the success of the project overall. That's where our airtight layer is going to be, which is going to ensure that we have very robust airtight building envelope assembly. And then also, that's where our insulation layer is going to be, which should be continuous and sufficient enough so as to be able to meet the stringent climate-based specific design protocol. So really need to be thinking about how do we ensure that we have as low of losses as possible without thermal bridging in our design. That may be challenging, especially if you're working within, a multifamily sector or commercial building sector. These sectors, perhaps it's building without thermal bridges is not necessarily something that every designer thinks about. So, you may be a developer or a project team who's really considering doing passive house, and you have an architectural team that, creates all of your designs. You may feel like they would be able to understand the concept of how to appropriately add additional layers of insulation in order to boost the R value of the building assembly. But are they able to detail those assemblies so that it mitigates all thermal bridges? Those are the things you're going to have to think about from the very beginning. You're going to have to make sure that the people who are detailing those plans really understand what we're trying to end up with, because the last thing that we want is to add a lot of insulation to the building, but only to have thermal bridges that could lead to some type of a thermal bridge condensation-related durability failure. That's the last thing that we all want. Thermal bridges aren't just about comfort or energy loss. They are also about building durability first and foremost. So start thinking about it from that point. At the same time that we're talking about reducing thermal bridging through having a continuous layer of insulation, you need to be thinking about how to make the airtight layer continuous. Once again, as we move into larger and more complex buildings that are attempting to meet the Passive House certification standard, detailing all those transitions of architectural features becomes that much more complex and challenging. We're moving out of the realm of lower scale single family and low rise multifamily structures into high rise, mid rise, and even commercial buildings or institutional buildings that have more interesting architectural features that maybe result in us having to really think more critically from the very beginning about how to detail the air tightness layer so that we are able to meet the Passive House thresholds of 0.05 CFM50 per shell area. And then thinking about the windows in the building. The windows are important not just because we want a higher R value window or lower U value window. We need to be thinking about how those windows are going to be installed. Once again, you don't want some kind of a building durability failure that's caused because of poorly thought out implementation of installation of the windows. You need to be really thinking about how you're going to get those windows installed in typically a thicker building wall assembly than maybe what you're typically used to working in a standard construction project. Also, you have to think about the amount of solar gain that you're going to be bringing into the building, because if anything, we have found since the inception of Passive House Institute US standard here in the US is that because of the unique nature of the United States climate, where we have most zones of the United States have at least some type of cooling demand, we have more of a propensity of overheating buildings than underheating them. It's actually not uncommon to find passive houses in cold climates that really don't need to heat, don't need all extra auxiliary heat. They really maintain themselves fairly well through solar gain. However, if we don't pay attention to how much gain we're bringing in on what side of the building and what appropriate SHGC we have on our windows, we may run the risk of overheating the building, causing us to use excessive amount of space cooling energy, and then also making occupants less comfortable. So these are all the things that you need to be thinking about when it comes to the envelope. It needs to really start from the very beginning, and these are the types of things that you're working through. After you start to get through working on what the envelope is going to look like, then you can really start to focus on mechanical systems. And the reason why we start with the envelope first is because through designing your envelope and understanding all the R values that you're going to have in all your different areas of the building, and also your your window locations, sizes, and the solar heat gain that you'll be bringing through those windows, you'll be able to more appropriately design mechanical systems to really process the loads that are specific to each individual zone of the building. And I'm referring to zones of the building because you really need to start thinking about the building more like that, because we're typically having smaller, less complex mechanical systems installed in passive house buildings, you need to make sure that whatever the mechanical design that you implement really achieves uniform comfort throughout the entire building. Because of that, it may be possible that although you may have say a ductless mini split heat pump that's more than appropriate to meet the load of a dwelling unit in an apartment, well, maybe if you have that just in one centralized location, it may take care of heating okay, because if you dump heat into one central part of a building, it will go from hot to cold. That's just how thermodynamics works and how energy transfer works in buildings. However, in the cooling season, the cooling that comes out of the mini split head is not going to know to go to where people are hot. So you're going to have to think about ways to be able to convey that space conditioning throughout the building in the most appropriate manner. So that's why I talk about design mechanicals per zone. You may even, maybe we're only talking about a single family house. However, that single family house is likely to have different space conditioning zones or zonal requirements. When you're doing a ducted system, it's a little bit easier because we're able to design our duct system and damper it down really in order to get sufficient amount of airflow to condition different spaces of the building. That's sort of the principle of doing load calculations, system selection, and then duct design. But oftentimes in passive houses, we're trying to go with less sophisticated, more simplistic mechanical systems. Once again, mini split heat pumps are fairly simple. They're just a cassette on the wall, and there's a lot of value to that because they do both heating and cooling. They don't have any ducts, which can be installed improperly at times. However, mini splits don't always necessarily do distribution very well. Certain designs, they work really well. Very open concept floor plans, they can work very well. However, if you don't have an open concept, it may be difficult to especially get the cooling energy to the areas of the building where you may have more solar gain, localized solar gain. So these are the things you got to be thinking about. And then, beyond thinking about, how are you going to create a design to be able to keep people comfortable, what about your installation and on-site execution? What are the expectations of the practitioners involved in that process? For PHIUS Plus certified projects, if you're using any type of a ducted system, the HVAC contractor has to be an ENERGY STAR qualified contractor. So they need to be working through the ENERGY STAR design, installation, and certification process in order to participate in PHIUS Plus. This is because PHIUS Plus has a relationship with the DOE's Zero Energy Ready Homes program, which references ENERGY STAR version 3 for homes. So, we need to be thinking about, if you are doing ducted systems, you need to make sure you have a credentialed contractor that really understands the program and understands the expectations of a quality design, install, and execution of their product on site. Then finally, don't forget about the details, all the extra details that go into a quality product. PHIUS has additional ventilation requirements that go above and beyond your standard project. We're not just meeting ASHRAE 62.2, we're ensuring that we have enough ventilation air so that we achieve roughly a 0.3 ACH of air transfer in the building when you combine ventilation and infiltration. Well, our infiltration loads are very, very low, so we're going to have to get enough mechanical ventilation in order to be able to deliver that amount. However, especially when we start to get into the realm of apartments or very small dwelling units, we also have to think about spot ventilation, because spot ventilation is a very critical part of having a robust design with solid indoor air quality. We need to think about, where are we taking, our extract air from, and if it's coming from, if we're designing our exhaust, in kitchens and bathrooms to be tied in with our ventilation system, we may have to have some kind of a boost mode in order to ensure that we're able to extract enough air when we're doing any cooking or to people are taking showers in their bathrooms, because we want to be able to remove those contaminants from the building envelope as quickly as possible. The other details of the Zero Energy Ready Homes program are really important as well. Once again, PHIUS Plus certification requires that you also meet DOE's Zero Energy Ready Homes program. And as part of Zero Energy Ready Homes, it requires adherence to Energy Star version 3, as well as EPA's Indoor Air Plus requirement. So for example, with DOE Zero Energy Ready Homes, there's an additional requirement for a robust, high-performance hot water distribution system. So it's not good enough to just have any old hot water distribution system in a passive house any longer. We need to actually have an intentional design for a high-performance hot water distribution system in passive homes as well, vis-a-vis the requirements of the Zero Energy Ready Homes program. Also, because Zero Energy Ready Homes requires adherence to the EPA's Indoor Air Plus program, that means you need to start thinking about other aspects of indoor air quality in your project, such as, are you building in a radon zone, a zone of the country that is labeled as EPA Zone 1, which has a higher possibility of radon concentration, in which case you need to build the building with some type of radon resistant construction strategy so as to eliminate the possibility that radon becomes an indoor air quality issue. So thinking about an overall high performance design, once again, you're going to start with your envelope. You're going to start with continuous insulation and minimize thermal bridges. You're going to move through to how to create that airtight layer. And really, you can do with those in either order. Some people might argue that it's wiser to start even with your airtight layer first and then move to the insulation layer. That may make a lot of sense in certain instances. But either way, you're going to think through those first two issues initially. Then you're going to think more about your windows. Where do you want your windows to be located? How do you achieve a low installed U value, which may require that you do some type of over insulation of the frames depending on your particular design and how many windows that you have and what kind of product you're using. And don't forget about the solar heat gain through those windows. How do you ensure that you have an appropriate amount of solar heat gain and not excessive amount that could lead to comfort issues in the building? After you make those decisions, then you can really start thinking about the design, load calculations, and distribution system for your HVAC system. And then, in addition, at that same time, you need to really be thinking about all these other aspects of a high-performance design, including hot water distribution, low VOC products, because certainly we don't want to have products that are going to contaminate the indoor environment when we have such an airtight home. Quality filtration, lights and appliances, so on and so forth. So there's really two stages, once again, to a quality process. There's the design process. And that's everything we've talked about thus far. Starting from the very inception of the idea that you want to meet passive house, you need to start thinking about how your design is going to incorporate all these different ideas so that the execution on site is more simple and achievable in meeting the intent of the program. And then, once you have a really quality design, you're ready to build, and it's all about execution at that point. So when beyond the design and the build process, we also have testing requirements associated with PHIUS Plus, and we do testing in order to ensure that our details really were achieved. We need to make sure that all of the insulation that was specified by the project team that went into the energy model actually gets installed in the locations and the thicknesses and materials as specified by the design. The blower door test needs to demonstrate that the building met the performance targets of the program standards. Our ventilation systems need to be commissioned to demonstrate that they actually are delivering enough fresh air into the building to achieve that 0.30 ACH of air transfer in the building, and that we have sufficient spot ventilation. HVAC and hot water commissioning is also required, because if we have HVAC systems and hot water systems in the building, we need to make sure that they're set up to run appropriately, so that when people do need space conditioning and they do need hot water, that they're actually going to get it when they need it in the most efficient way possible. Infrared imaging comes at the end of the project to really make sure that no details were missed and there isn't any potential of any failure that was not obvious. There was no settling of insulation in building assemblies, so on and so forth. And that, ultimately our ventilation electrical testing ensures that, the ventilation air, although we have enough airflow, we need to make sure that it's being delivered in the most economical manner possible. Mitigated. We tend to see a lot of blown building assemblies with continuous insulation on the outside of some sort. If you're not planning for that, that's okay. There's a lot of ways to arrive at a quality end product. It's all about the design. I've seen very quality installed fiberglass bats in passive homes, and there's nothing to say that they can't work. As long as they're installed per manufacturer's specifications and all the other continuous insulation details are met, why not? However, there are other products that tend to maybe arrive at a more robust end product more easily. So, you might consider about what kind of insulation materials or do you really want to use. You may have some other, needs or desires in mind. Some people are trying to build not only low energy buildings, but they want to have low embodied energy. So they may consider products such as cellulose over something like spray foam because they want to have low embodied energy. Or you may choose to use, because you're interested in designing for fire resistance, maybe projects may choose to also use like rock wool board on the outside of a building instead of continuous foam board insulation. So these are the kinds of things to start thinking through. For insulation, make sure it's thick enough. You need to have enough insulation to be able to meet your climate-based designs in order to meet the annual and the design load requirements for the program. You want to have it designed so it's thermal bridge free, at least, to the greater extent possible. If not, then the certification team, Lisa and or Graham at PHIUS, are going to make you go through and do therm calculations in order to detail what kind of impact do those thermal bridges have on your design. In terms of tight building assemblies, once again, please ensure that you draw that red line around your entire project in order to show how all those intersections are going to be detailed so that you have a continuous airtight product. Wind tight, you don't want to have any wind washing. If you've got outboard loose insulation, you don't want to have any type of wind washing that then diminishes the R value of your product. You don't want any gaps within your insulation. Once again, if you're using a bat product, whether it's fiberglass bats or cellulose bats or rock wool bats or whatever type of bat product, these are 3D polygons of insulation going into 3D polygon-like shapes of cavities. And oftentimes have pipes or wires or other types of obstructions in the way. You need to make sure that they're installed in such a manner so as to ensure that the insulation in the cavity truly performs as we need it to. For air tightness, once again, a continuous envelope. We need to use the appropriate materials for this as well. The type of materials that we use should last ideally forever. We want to not just build a passive house for today, but we want that the building should perform the same way in 5, 10, 20, 100 years from now if possible. So what kind of materials can we use to ensure that that level of air tightness will really last and be durable? Our typical caulk and foam approach to other types of energy efficiency programs may not work for this reason. And you need careful planning. Once again, you may not just be able to rely on spray foam or caulk to be able to really seal your building envelope. You're probably going to need a more robust plan that really includes a continuous air barrier, which is detailed at all the transitions. And we need to be able to see that air barrier before we close it all up. If we aren't able to see it at the very least, or better yet, test it prior to enclosing it in dry-walled assemblies, well then we may not be able to fix any problems that were correctable prior to closing everything up, which may imperil our opportunity at meeting certification to begin with. And it's not just about meeting a certification. The reason why we have these stringent air tightness requirements is because there's for good reason. We know that moisture, or most of us should know that moisture is one of the greatest harmful contaminants to the life cycle of buildings. So what this demonstrates, this image that we see here, is that diffusion would only cause, so diffusion through, so basically moisture, water vapor that is diffusing through a building assembly, would only cause about 1 gram of water per day per meter square to go through this assembly. However, because we have a continuous gap that's running between inside and outside, we have 360 grams of water that are moving through that same assembly. So from what we can see here, detailing any type of cracks or gaps in our building envelope, our continuous airtight layer, that's going to ensure that we have the least amount of moisture risk involved in our building assemblies than worrying about, the permeating of our building assemblies. Don't get me wrong, ensuring that we have an appropriate, breathable building assembly is also really a critical part of a passive house design, but first and foremost, you have to think about air tightness, because air moving through building assemblies has much greater of a risk at causing significant failures than just the permeability of assemblies. So, what kind of materials are you going to use, and how are we going to be able to observe those, the application of those materials? This is why we tend to see a lot of tape or gasket type of products installed in passive houses, because whereas caulk and foam, they can do a good job. You can use caulk and foam appropriately. The problem is that caulk and foam can be damaged through, wires or pipes being, moved throughout the construction process. And then also, sometimes there's small, tiny, microscopic, holes or gaps that are in some of those air sealing details that are easy to miss. With the naked eye, it appears as if something is sealed, but in reality, some of that caulk or foam is cupping in some area, or incomplete filled, and we don't actually have complete air tightness. So that's why we tend to see products that are a little bit more self-evincing and very easy to identify that they are properly installed. For windows, usually you're going to have, we're going to have to think about what kind of thermal performance do we need. If we're in a more modest, maritime climate, perhaps, San Francisco, or maybe we're in Phoenix, Arizona, we may not need triple pane windows. However, most of the country, you probably want to use triple pane windows in passive homes, because that's the highest performance product that we really can install, and windows are one of the weak spots of the total thermal performance of the building. So in most cases, you are going to go for more like a triple pane window. Think about things like the spacers, so that we have low conductivity spacers. Frame, once again, ideally as low conductivity as possible, and perhaps even over insulated on the outside or inside of the building, so that you're even more thoroughly reducing heat transfer through that frame. The installation should be thermal bridge free. Once again, maybe an outboard layer of insulation is necessary to ensure that we have enough insulation around the rough opening of the window. And most importantly, even more importantly than whether it's a double or triple pane window, or what kind of SHGC you have on the window, how do you properly install that window to flash it properly to address the rough opening, so you don't have any type of water intrusion or buildup that can lead to a long-term failure. So on site, we're going to be verifying, how did you install those windows? How did you detail the flashing? What kind of products did you use to really result in a high quality install of those windows? Because windows, even in a passive house, are one of the weaker spots of the building. And we have to address those weaker spots to ensure that we have a quality end product. For mechanical systems, once again, we're going to start probably with our ventilation system. Our ventilation system is the most critical mechanical system in a passive house, whereas conventional types of energy efficient designs may start with a higher performance furnace or heat pump. We're not as worried about those first and foremost because typically our loads are very low. They're very modest, and we may be able to try other types of space conditioning systems in order to really meet the needs of our project's demand. But before we do that, we have to make sure we have enough ventilation and a ventilation system that's going to have a strong amount of heat recovery. It has the capability of also doing spot ventilation. If not, then we're going to have separate spot ventilation systems, that are intermittent, which may then require there to be makeup air that is tied to those systems, which becomes a little bit more complex and cumbersome. And then, how do we design and install the duct systems for the ventilation system so that they actually deliver the air where we want the air to go in the building? I've seen plenty of, unfortunately, I've seen in passive houses as well as more conventional energy efficient designs where ventilation system ducts are treated much differently than heating and cooling ducts. They are not appropriately sealed, and because of that, the airflow really doesn't go where it needs to go. Or the ducts are, sized too small, or they have bends and kinks in them that normally for heating and cooling ducts we would never allow, but for ventilation people feel like somehow they're different. However, our ventilation system, once again, is the most critical mechanical system in our passive homes. So we need to ensure that we have a quality design and install of those ducts. For any type of space conditioning that's needed, we need to make sure that we have appropriately sized systems. They can't be oversized. And that can be a challenge. Oftentimes, it's challenging to find an appropriately sized system that we feel confident will meet the loads of our building in both heating and cooling season, but does not result in oversizing and short cycling of the system in one of the two seasons. It's a little bit of a challenge if you're going to do both heating and cooling. And then, distribution. Are you going to have distributed heating and cooling, or are you going to go for non-distributed systems like a ductless mini split heat pump, or maybe just an electric resistance radiator? Well, those may work okay for heating. If you're trying to do air conditioning, though, that may be challenging to keep all zones of the building comfortable without any form of distribution. For this reason, we see a lot of passive house projects moving towards having ducts in them for heating and cooling, even though they would prefer not to, take on that additional cost and design challenge. Ultimately, it just makes it a lot easier to distribute heating and cooling to keep people comfortable throughout the building. And then, how to keep these systems within conditioned space. That is a requirement of the Zero Energy Ready Homes program, that all thermal distribution systems are completely within conditioned space. Therefore, it also is a component of Passive House Institute US certification. And HVAC systems, it's not just as easy as, meeting the load, and you have to think about all the other requirements that come with it, proper installation of ducts, sealing of ducts, testing of ducts, commissioning of the systems to make sure you have the airflow going where you need them to go, having balancing dampers and diffusers for that reason so that we can more appropriately adjust the amount of airflow and therefore the amount of load distribution throughout the building. Sizing ducts appropriately. Oftentimes, we're going to have oversized ducts just by the nature that we're moving small amounts of air in passive houses. So you're going to have to make sure that you really have good dampers to be able to damper down that airflow, but without, raising external static pressure on the system excessively then. Balance airflows between rooms. We want to make sure that the air is able to move freely throughout the building, and for that reason, the radar tests each bedroom to be within plus or minus 1 Pascal in ventilation only mode and plus or minus 3 Pascals in heating and cooling mode. Control systems need to be set up in a logical fashion. Otherwise, you might have some unintended consequences of some type of, electric resistance, system that may be set up in order to defrost a ventilation core, but unfortunately it wasn't set up properly, and then it's constantly running, causing there to be a lot of waste heat going into the ventilation airstream. That would be an unfortunate consequence. It's happened in a passive house. We've seen it. So design and execution of the controls is just as critical. So, you start thinking about all these different things that you have to do, and it's a lot to take in. So that's why you really want to start with this sort of like a design checklist for your design team. So starting with the site design, how do we really have the best possible building shape, site density, orientation, so as to meet this project and really have it be as successful as possible in meeting passive house. In terms of, development and permitting, making sure that, the amount of insulation that you plan to have in your envelope won't cause any type of lot setback issues, or that, you have a good plan for how you're going to have, jam extensions installed, so on and so forth. Just making sure you have room for all these different attributes of the building, because we can't just get to the end and say, oops, we forgot to make room for this duct chase, and now we're going to have to put it in the attic. It's not allowed in passive houses. We can't have ducts in the attic. So you have to start thinking ahead of time about how you're going to really run these things, or else you're going to get to the end and you're going to be out of space and you can't build down anymore, and then unfortunately the goose is cooked. So you have to think about these things from the forefront. Building envelope load, envelope assemblies, once again, how are you really going to detail all these? You need to have thorough design drawings that show how you're going to detail with the specific products you want to use, the specific applications, because you don't just want to have some generalized design, because you're going to invariably give it up to a subcontractor, to a general contractor who knows much less than your design team does about passive house, and the subcontractor knows almost nothing about it, and that can result in overall that you ended up with a product that did not actually get installed properly because it was not detailed in the design drawings. So you need to think about these things and execute them, starting with the design. Heating and cooling, don't understand what you're using the space for. Don't allow your mechanical engineer to use their typical rules of thumb that they've used for every project that they've ever done since the 1980s in order to size systems. And I'm not trying to make fun of mechanical engineers or anybody in particular, but once again, not everybody on the design team or other contracted parties involved in a project fully understand what we're attempting to meet and how we're going about attempting to meet such a high performance energy design, and therefore they may be inclined to use certain protocols that are specific to other types of building projects, or more general to other types of building projects, but not specific to passive house. So, have those conversations with your mechanical engineers or whomever else is doing the system load calculations and system sizing and design for space conditioning. And then for mechanical ventilation, once again, this shouldn't just be treated like it's the last thing to think about. Oftentimes I find in other type of just standard building construction projects, code compliance projects, or Energy Star or some other type of lower level energy efficient design, oftentimes ventilation systems, they're kind of like the last thing that anybody thinks about. And oftentimes that's how they're treated. They're treated as if they're the last thing that really matters, and they're not always designed properly. We don't necessarily see that the ducts are treated like they are the ducts, the primary airflow conveyance ducts in a project. Therefore, they're not sealed, or they're installed with bends or kinks or other types of problems that for heating and cooling ducts, I think most of us would always look at that and say, oh, that's not right, that's going to lead to problems. Well, the same thing is going to lead to problems in ventilation systems. And unfortunately, these are those systems that are typically running 24 hours a day, 7 days a week. So if you really botch the design and installation of the distribution system for ventilation systems, you're going to lead to problems. We've seen this oftentimes, unfortunately, where you have once again an HVAC contractor or a mechanical designer, MEP firm that they're a high quality firm, but they just don't understand exactly what we're trying to do with Passive House or how critical the ventilation system is for Passive House, and therefore they don't really detail like the air sealing or duct sealing, I should say, of the duct distribution system. And because of that, we're not getting the kind of airflow that we need out of where we had designed to bring it from. And because of that, that results in having to turn up the ventilation systems to max airflow to even try to approximate what the design was for airflow in the building. At the end of the day, that can then lead to a lot of problems in burning out systems early, high external static pressure, and overall greater energy use in terms of watts per CFM delivered than we had intended for our project. And that's a major influence on primary energy in Passive House certification. Our primary energy is heavily influenced by the electrical performance of the ventilation system. And so we really need to make sure that we get all these details correct, because if not, we may end up with a system that really doesn't really meet the intent. We've had to have ventilation system ducts aero sealed after a project is complete because they're all buttoned up inside of drywalled assemblies. No way to really get to them to air seal them at that point or duct seal them at that point, other than using something like AeroSeal, which can be injected. Thankfully that's an option, but we don't want to necessarily rely on that. Plus it's very expensive. And if you already have a tight budget for your Passive House project, you probably don't want to add unnecessary extra costs at the end. Plumbing and electrical, these are also components of Passive House. Oftentimes people think of Passive House as just being about building envelopes and super airtight assemblies and super insulated assemblies. Those are the most critical first things to think about. The assemblies, and then thinking about HVAC, and ventilation, but don't overlook plumbing and electrical, because with the Zero Energy Ready Homes complimentary certification under Zero Energy Ready Homes, it is required for all Passive House projects that there is a higher performance hot water distribution system. So you need to think about how you're going to lay out your plumbing in the most efficient way possible so you don't have excessive hot water standing in pipes, which can lead to excessive hot water distribution system loss. And water and hot water waste as well throughout the project. For electrical systems, this may seem fairly simple, but we need to have 80% high efficacy lighting throughout the building. That's not necessarily it's something that we always see even in a Passive House, but is a requirement through the Zero Energy Ready Homes. And then, also, in terms of construction management, really, that was all the previous what we discussed was really from a design standpoint. From a construction management, you need to talk about the same details, but how is the construction team going to address all this? How are they going to manage their subcontractors and have their site supervisors really set up in order to really pay attention to these details so that they're executed on site? It's great to have them in a design, but if you don't have the conversation about how they're going to be executed, they probably won't be. Once again, even if you have the greatest GC involved and his subcontractors are really, they really understand overall what they're supposed to be doing, there's oftentimes subs of subs. So, the GC subs out the HVAC work to to an MEP firm, and the MEP firm subs out the duct install work to some other type of duct installation, specifically a duct installation company. They don't do anything else except for install ducts. Well, they may not get the memo that this is a passive house project and this is the way we're doing it for this particular project. So you got to make sure all the way down the chain that everybody understands what the intentions are, and that nobody has a bad attitude about it and is going to take the day off. Otherwise, we're going to end up with problems at the end of the project. In addition, you may have subcontractors who you may never even really think are involved. The electrician in a project. Well, what do they have to do with passive house? Yeah, we need to have 80% efficient lighting and a couple other efficient electrical devices, but really the electrician's not that well involved. Well, they might be though, because especially if they need to run their wire in a certain spot, you don't want them to somehow damage or encumber our building assemblies or our airtight layer, or somehow our air distribution systems. These types of things happen. I'm sure we've all seen it, where some well-intentioned but frankly ignorant subcontractor imperiled the durability or the intentional installation of ducts or air barriers or insulation layers. It's happened. We've all seen it. And these are the kinds of things that you need to think of. How is that going to be managed on the job site? Because we do have a rater involved in the project, but unfortunately the rater can only be there a certain amount of the time. They can't be there necessarily every day, making sure that people who are working on the project are doing their perfect job to really not imperil the project's certification. So you're going to have to really have those conversations as an overall team to ensure that mistakes aren't made. However, mistakes may be made, or we just want to make sure that they weren't made. And for that reason, we have an on-site verification program through the PHIUS Plus certification. PHIUS Plus was created in 2013 as a collaboration between PHIUS and the Department of Energy. So the essence of PHIUS Plus certification is that for all projects contracted with PHIUS on January 1st, 2013 or later, we're good to go through PHIUS Plus certification. And PHIUS Plus was based off of originally the same European performance metrics, which have now moved to the PHIUS Plus 2015 climate-specific metrics. Having the consulting and modeling done by a certified passive house consultant, and then on-site verification and testing performed by a PHIUS Plus rater. PHIUS Plus incorporates Energy Star new homes, DOE Zero Energy Ready homes, and EPA Indoor Air Plus certification as co-requisite certifications in order to earn Passive House Institute US certification. There are some exceptions. Projects in California, Alaska, and international projects are exempt. The reason why is because in California, the energy modeling done to demonstrate compliance with zero energy ready homes is at this point less popular, not always performed necessarily. So at this point, we do not require it for California projects, although that's being discussed to potentially move to adhere to that. Alaska has a similar situation. They don't really adhere to national certification protocols for homes. They have their own state-specific standards for how they do on-site verification. International projects, they can't meet the U.S. certification standards. It's just not available there. However, we do require that even if projects aren't certified under these additional complementary standards in California, Alaska, or international projects, that all of the requirements are still met. Once again, if the project was contracted pre-2013 with PHIUS, then they do not have to meet these additional requirements. And we did not require adherence to these standards for multifamily projects up until 2016, the beginning of 2016, when the version 2.0 PHIUS Plus multifamily standards were released. And actually, Those standards are attached as the handout that you can download if you're interested in seeing the specifics of that multifamily standard. For commercial buildings, Energy Star and Zero Energy Ready Homes do not apply. Once again, though, we expect a lot of the details from those programs to be implemented. So why do we have a PHIUS Plus certification process? Well, it brings about on-site verification, which is really critical. And it's really critical because we can have the greatest building plans with excellent specs and a really, quality energy model that shows that the building is going to use very little energy. However, if that's not actually verified on site as having been executed, we don't know that we actually have that as a finished product. So it brings about an additional layer of quality assurance to know that the design and it was implemented into the construction on site and verified by a professional that is specialized in these types of high performance verification principles. And then we also have added value through integrating with Energy Star, Zero Energy Ready Homes, and EPA Indoor Air Plus, because really these government-based standards are really built upon some of the best of the building science world of best practices for implementation in a high-performance construction environment. So we feel like there's a lot of additional value in adhering to those complementary standards. So the way it works is that there's on-site verification performed by a PHIUS Plus rater. Reason why we have a separate professional aside from the CPHC is because very few CPHCs are experienced on-site verification professionals. Also, oftentimes the CPHC may have some geographic challenges in participating in the project. They may be living in Alaska and working on a project in Florida. Well, it's going to be very difficult for them to really maintain an overall quality oversight of a project when they're that far away. And I'm not just being hyperbolic when I suggest that a consultant could work on a project in Florida, because we've seen it. For quality assurance, basically, PHIUS Plus raters, they have a relationship with a quality assurance provider that is able to give them additional support in how they might be able to go about executing the on-site verification and really ensuring that that whatever they're seeing on site really meets the intent of the program standard. We then, as a program, PHIUS performs additional QA and QC after the rater has gone out and done their verification. The end result is that we're able to really stand by the validity of our product. When PHIUS stamps a product as being a PHIUS Plus certified project, we can stand by that and know that the claimed performance in our energy model matches the on-site verified actual performance of the building. Once again, these other programs have different types of best practices that they bring to the table for detailing indoor air quality and durability results, HVAC and hot water commissioning, and also with the Zero Energy Ready Homes program, they also have a requirement to set up buildings in certain areas of the country with high solar radiation on a daily basis to be zero energy ready at some point. That makes a lot of sense, because with Passive House, you're basically building the most efficient product that you can really before it is no longer cost optimal. So at that point, in order to result in a net zero project, all we need to do is add an additional amount of on-site renewable energy. PHIUS, through this partnership, has the ability to be the ultimate step in a continuum. We kind of step up from IECC Energy Code compliance to Energy Star New Homes to the DOE Zero Energy Ready Homes program, and then PHIUS Plus is viewed as being sort of the ultimate step on that continuum. And it makes sense because our goals are aligned with these programs as well. Energy Star is trying to progressively step down the amount of energy use in buildings. Zero Energy Ready Homes takes the next chunk off the top, and then PHIUS really goes the next distance to really give you really, once again, as high a quality of efficiency in a building that you can get before it's no longer economically feasible. So how does the rater do their on-site verification? Well, they typically phase it in different site inspections phases. At a minimum, you're going to see 2 on-site inspections. However, a rater oftentimes will perform up to 4 or possibly even more on-site inspections in order to really ensure that they're able to verify all needed details of the project. So oftentimes you'll get started with the site visit 1, which will be verifying any type of fixed shading, operable shading, adjacent shading that might come from trees or adjacent buildings or mountains, or, you know, if you're in a city, you know, once again, adjacent buildings or other structures. Really making sure that the building matches the plans, and that especially windows and doors are are the actual size and location as is described in the plans. Taking a look at, you know, foundations. Do the foundation walls match with plans in terms of their layout and location? What about slab insulation? Are there any issues with the detailing of the slab? This was actually an example where the section where the stem wall for the stairs was detailed had no insulation underneath it, so it's actually a giant thermal bridge. This wouldn't have been caught had the rater not been there, and it turned out that they had to do a fairly extensive therm calculation in order to show the thermal bridge through that stem wall for the stairs. Air barrier detailing. The rater is going to verify on site that, you know, really your air barrier is continuous throughout the entire site, because we don't want some type, you know, although we're going to be doing blower door testing to show that we meet the airtight performance, we don't want to have some type of localized deficiency in our airtight layer that then leads to some durability issue. Thermal bridge-free detailing. Once again, we want to make sure that there's continuous insulation throughout the whole project. Also, any cavity insulation is installed at a grade 1 level of performance, or at least a grade 2 level of performance with sufficient continuous insulation on the outside, so as to meet the requirements of the Energy Star New Homes program. So once again, you know, this is what I would consider to be a grade 1 level of insulation installed, because it thoroughly fills the cavity and is shaved down. But we're not always going to have that robust of a product installed. If it's a less consistent product, we may have more struggles in verifying it. Oftentimes, the rater during one of the second site visits, or one of the later site visits, may do preliminary blower door testing prior to the installation of drywall on the walls, and this is really to ensure that, you know, are you really on track for meeting the air tightness provisions of the program? Thermal mass, you know, do you have any thermal mass that's incorporated into the project? What about if you have any thermal bridging mitigation strategies that we're using for windows and doors? You know, are the frames being insulated over on the outside like they were intended to by the design? These are the types of things that the rater is going to verify. Once again, infrared imaging could be really important to verify whether or not there's any settling or other types of deficiencies in the insulation layer of the building. Ventilation system, there's a lot of things to verify by the rater. Ensuring that, you know, they're really, you know, all the ducts are properly insulated, straight, airtight, and that the airflow is going to the appropriate places in the rooms throughout the building, and that that we have appropriate filtration, and that ultimately the watts per CFM are within the specification of what the project team intended. For ventilation systems, also oftentimes there's ground loops that are used in order to pre-temper the air that's coming in, or to serve as a defrost mechanism. You want to make sure that those are set up properly, and that really the controls for whatever type of defrost system are set up to run in the way that the project team had intended. We have to check to make sure that the duct design matches what was on what the project team intended it to be, and that we do testing at the unit to make sure that the airflow is in balance at the unit, and then doing testing at all of the registers and diffusers throughout the project, so that the ventilation air that we had intended to be delivered throughout the building really matches that design. Because we have, in any type of, because we have ventilation systems and oftentimes heating and cooling systems that are distributed, we want to make sure that all the zones of the building, so all the different rooms are really within balance with one another, so you don't have excessive pressure buildup in any particular room, which doesn't allow that airflow to escape. For this reason, the rater is going to be doing on-site verification of room pressure relief systems, such as undercuts or transfer grills. Once again, electrical measurements also performed for ventilation systems at a minimum. Heating, cooling, and dehumidification systems need to be commissioned and installed properly. The rater doesn't necessarily have to perform all the startup testing. They can collect a lot of that information from the HVAC contractor, but the systems do need to be commissioned properly. Duct leakage testing. Raters are going to perform duct leakage testing. Ideally, there shouldn't be any duct leakage to outside within a project because we shouldn't have ducts leading outside the home. However, we need to make sure that the total duct leakage is proper so that we don't have excessive leakage, throughout the building. We really want the airflow to go where it was intended and designed to go. External static pressure, so as to make sure that the heating and cooling systems are set up to deliver an appropriate amount of airflow, and they're not going to be using excessive amount of electricity in their normal operation. Hot water systems. Are the pipe layout and insulation, does it match what is in the passive house energy model? What about any solar photovoltaic systems? If they're installed and helping to help meet the primary energy demands of the project, do they match what was included within the project specifications? Lights and appliances, once again, you need a minimum of 80% high efficacy lighting throughout the project, and all appliances installed have to be Energy Star. So this is sort of just a very brief overview of what the PHIUS Plus rater does. Really, their scope of work is very extensive, and you're going to have to work with them from the very get-go to ensure that you are properly phasing when they're going to come to the project, what they're going to verify at each stage, and if they can't make it to a particular stage, how you're going to be able to get them the documentation that they need so that they can really stamp their name that the project meets the design. So for example, if for whatever reason the rater can't be there in order to verify the slab installation, you're going to have to take photos or video or some other types of method of really conveying to the rater that the project did what was in the design and it was verified as being thorough and complete throughout the entire project. And the reason why they're going to need to know all this is because the rater is liable, or they are responsible, I should say, instead of liable. Liable is not the right word necessarily, but responsible for the project and the verification of the project. PHIUS does an ultimate review on the submission from the rater to ensure that the documentation provided by the rater is sufficient and thorough enough so as to document that they verified all major systems and components of the building and its design. So through this, we perform our final design as a PHIUS Plus QA/QC certification team. So kind of the first step to this is, project teams, they need to find a CPHC, and they need to have that CPHC when they do their energy model on the project, submit that for pre-certification review. That's if you all, attended session number 2, Lisa White, the certification manager with PHIUS. That's really the scope of work that she performs, is reviewing the energy model, the associated specs and documentation, so as to verify that this design will meet Passive House. If there's anything that they're concerned about, they will let you know at that time so that you can make appropriate adjustments to your model or to the design or both. Then you need to, hire your rater. Ideally, you would hire both at the same time so that they can all be part of a collaborative team. But at the very least, once you have your design pre-certified, then you need to, make sure you have your rater on board so they can really get started with their on-site verification plan. All of their documentation is going to be reviewed by the program at the very end. So submit this, basically the documentation for pre-certification that you need to be submitted includes a complete WFI model, project drawings, which include site plan, with whatever type of shading is going to be used, design drawings, including sections and elevations, detailing of the thermal envelope, including an explicit identification of your thermal boundary and your air barrier, and then your ICFA calculations. Data sheets and specifications are necessary to validate all the inputs in the energy model. And especially if you have anything specialty such as earth tube efficiency calculations, specific solar shading calculations, so on and so forth. All this information needs to be available for pre-certification. Pre-certification occurs upon PHIUS accepting that your model matches your design and the specifications. And you receive a document stating that the project is pre-certified, and it gives confidence to you all, your team, that you're actually going to be able to meet the certification so long as the PHIUS Plus rater is able to verify that you did so in the execution. Once the rater goes out and does their final verification, they're going to submit all that documentation to the program so that we can perform one final review. And basically, we're going to be checking to see what changed. Was there any difference between what the project had put in their energy model and what the rater verified? There invariably is. There invariably are changes to infiltration. You probably didn't get exactly what the number was that you put in the projected model. It's probably a little bit lower, hopefully, because hopefully, your design incorporated, a higher level of infiltration performance. In terms of the other types of documentation review, beyond just the testing, we have created a rater workbook that details all the specifics of the program and the on-site verification criteria so that the rater can send that to us. That incorporates all the Energy Star and Zero Energy Ready Homes and Indoor Air Plus requirements as well. The rater also sends in a REM rate file so that we can do a comparison between their model as well as the model for Passive House. That may seem a little bit redundant to people to have two energy models. Usually the rater's model can do some other things for your project anyways, such as help you to qualify for utility incentives or potentially the 45L Energy Efficient Homes tax credit. So talk to the PHIUS Plus rater about their need or requirement to produce an additional energy model at that point. It should be noted that we do have specific standards now for multifamily verification, for basically the certification requirements for multifamily. So this was released and is effective. This was released in 2015 and is effective for all projects registered with PHIUS as of January 1st, 2016. So if you have not yet reviewed this and you're planning on working on multifamily projects, I recommend that you begin looking into this more thoroughly, beginning immediately. So thank you so much for the attending. We have, sorry, I apologize. I do have one more slide, which is just to discuss the very end of the remaining schedule that we have for the developer series. So on April 28th, there will be a session on orchards at Orenco, which is one of the first PHIUS Plus verified multifamily projects in the country that is certified. Extremely airtight performance of this 3-story multifamily building. So any of you all working on multifamily buildings, I strongly recommend that you come to learn the lessons that can be taken from orchards at Orenco, because they really did a great job. And then on May 17th, 2016, there's an upcoming project in Kansas City, Missouri, that will be one of the largest passive house projects in the U.S. ever certified. So we look forward to having you all at that point for those upcoming sessions. At this point, I'm happy to take any additional questions that may have come in. Katrina, do we have any questions?
Yes, Chris, we do. I will read them off to you. I have a question that came in pretty early, and I feel like you may have addressed this, but it asks, how does Indoor Air Plus stack up against the PHIUS program, and what major changes would an Indoor Air Plus partner have to make for PHIUS?
Yeah, great question. So Indoor Air Plus, EPA's Indoor Air Plus program is a prerequisite of meeting the DOE's Zero Energy Ready Homes program. And as such, because the DOE Zero Energy Ready Homes program is a co-requisite certification for PHIUS Plus, that means that in order to be PHIUS Plus, you have to meet Indoor Air Plus. So really, how do the two stack up? Well, they really, PHIUS Plus has adopted the indoor air requirements of Indoor Air Plus. I'd say the only thing that really goes above and beyond Indoor Air Plus is really that we do not allow ducts to be outside the envelope, whereas Indoor Air Plus would still allow that. And in addition, we want MERV 8 filtration, not just for heating and cooling systems, but also for ventilation systems as well. Otherwise, we're really just building off of Indoor Air Plus. Also, I should say, once again, our ventilation performance for whole house mechanical ventilation, typically the ventilation rate is going to be higher than what you would have for Indoor Air Plus, which simply references ASHRAE 62.2. Once again, our ventilation system airflow for whole house mechanical ventilation is going to be sized to exchange 0.30 ACH in the building.
Great, thanks. The next question asks, with all the comments about making sure the design team designs to make sure the building will meet PHIUS Plus inspection and testing requirements, how about making CPHC and PHIUS Plus verifier review and approval of design documents prior to client acceptance of design, a standard part of the PHIUS Plus process?
Yeah, that's a really good point. So I would say that the intention is that the CPHC has done their review of the design because they're the ones who are submitting the energy model along with the design drawings and specs for the project for pre-certification. So the consultant, at the very least, definitely is involved in that review of all documentation prior to moving forward in submitting anything to PHIUS or attempting certification. The rater is not always brought to the table at that point, although it is my encouragement that I would say that you should bring your rater to the table early if you can, even before pre-certification, because the rater oftentimes, they've already worked on other projects that have successfully met Passive House. And they can tell you where certain systems worked and maybe certain systems didn't work. Maybe what some of the pitfalls were that they've seen through their own on-site verification work. So the rater is not just simply a passive third-party verification agent. They actually can help to really inform the design as well.
Okay, thank you. Next question. PHIUS Plus 2015 basically requires 4 certifications, as I understand it. How is the process streamlined across the 4 standards to make the certification process efficient and accessible?
Yeah, excellent question. So that is absolutely correct. PHIUS Plus certification does require essentially certification under 4 programs. It requires certification under EPA's Indoor Air Plus program, EPA's Energy Star version 3 New Homes program, and DOE's Zero Energy Ready Homes program, in addition to the other requirements of PHIUS itself. So in order to streamline these, number one, during the pre-certification review, the certification manager is going to ensure that you have the details in order for meeting these additional programs. So, for example, do you have a radon-resistant construction technique or radon mitigation strategy that's being implemented on the front end of your design so that you don't get to the end of the project and all of a sudden you aren't meeting something that is a requirement. They're also going to make sure that you're meeting the thermal bridge free construction details of the Energy Star version 3 Homes program. They're also going to make sure that you have a quality hot water distribution design, because they're going to collect pipe layouts and whatnot, and any type of specs for circulation systems, recirculation systems on the front end, so that during pre-certification review they can give you assurance that not only are you meeting PHIUS's requirements, but you're also meeting the requirements of these other complementary standards. In terms of the rater's review, we have a rater workbook that incorporates all of the requirements of these programs in a more streamlined and digestible format, so that the rater can fairly easily check off compliance for all those program standards and fill in the necessary checklists associated with those programs ahead of time. Thank you all. Thank you for joining us this afternoon. I hope you all learned a lot, and feel free to reach out to us with any further questions. If not, we look forward to seeing you at the next session.
Thanks, Chris. And oh, sorry, one more thing. One more question about the future events, April 28th and May 17th. Yes, those will both be webinars, and I will have the registration set up by the end of the week, and please look for that in the PHIUS newsletter. Hope to see you all there.